We're continuing to look at hot water systems, and now we're going to look at open vented and sealed hot water systems and the difference between them and what this means. You can actually sort of see on this very first slide the main differences between open vented hot water systems and sealed systems. I've got these two diagrams here. One on the left shows an open vented cylinder, direct cylinder heated by an immersion heater, and the one on the right again shows a direct cylinder heated by an immersion heater, but in this case it's a sealed system. And the key differences are the open vented system that would vent to a cold water storage system, be fed from a cold water storage system. The water in the cylinder would be under low pressure, and that's the sort of the key things about an open vented system right there. Whereas a sealed system would be fed from the mains and would be delivering high pressure hot water. So the objectives for this session, I want you all to be able to use the new terminology. We're going to introduce a lot of the names of the pipes and different terminology that we'd use in this unit. So we're going to be able to use this new terminology to describe open vented and sealed hot water systems. I want you all to also to be able to label drawings of open vented systems and of sealed systems with the pipe names and the minimum pipe sizes and also recommended pipe sizes. Alrighty, hot water systems. So we've already looked at direct and indirect in sort of the first part of hot water. We've also discussed that things can be heated instantaneously or they can be stored, and they can be sort of stored in a centralised location and feed lots of appliances, or they can be localised appliances which just feed one or a very small group of appliances. Okay, so we're going to look at the key terminology for the unit in this section. We're going to look at the pipe sizes, positions, and the key differences between open vented and unvented or sealed systems. So key terminology. We touched on this actually previously, but primary water. The primary water is the water in the heating circuit. Essentially, it's it can include the flow and return to the cylinder coil, or it would include the flow and return to the cylinder coil. So the primary circuit. If you ever hear anyone talking about the primary side or the secondary side, we're talking about either the heating side or the hot water side. Okay, so secondary water, this is the water that potentially could be stored in a cylinder, or it could also be the water that's delivered from a combi boiler. Essentially, it's the hot water that comes out of our taps. That's sort of the secondary water. Okay. Open vented systems. Essentially, it's a system that's fed from and would vent to a system in simple terms. You know, that's what an open vented system is. You can have open vented hot water systems that would be fed from and vent to a cold water storage system, like you can see here. You've got the cold feed, the secondary cold feed coming out of the cistern here, going into the bottom of the cylinder here. You've got the sort of vent. At this point, it's the combined vent and distribution pipe coming off here, with the vent pipe coming up here and discharging. If there is a fault condition, it would discharge into the top of the cistern just here, going through the rubber grommet like we talked about in the cold water module. Okay, and that's essentially an open vented hot water system. But you can also get open vented heating systems. Okay, you can see here, this is the primary cold feed, because it's a cold feed to the heating side, coming out of our feed and expansion cistern here, and that's sort of filling up. It'll be used to fill up our heating side. And also we've got a vent pipe, a primary open vent pipe, rising up here and venting into the feed and expansion system. Okay, so we can see that an open vented system would have a cold feed pipe and a vent pipe coming from or venting to an appropriate cistern. Okay, so we're going to look at the pipe names and positions of these systems. Okay, hot water distribution pipe. That's the name of a pipe which will distribute low pressure water, low pressure hot water, in this case a hot water distribution pipe. Okay, because this cylinder's being fed from storage, we know it's going to be delivering sort of low pressure water, so therefore the pipe which comes off of here will be described as the hot water distribution pipe. The main run of that will be 22 mil until it gets to the bath, and then it can be sort of reduced to 15 going to the basin, excuse me. It can also be reduced to 15 at this point going to the kitchen sink. So the minimum size for the hot water distribution pipe is 15 mil. The main runs and the run to the bath will be 22 mil. Okay, I think we've just covered all that already. Okay, so secondary cold feed. This is a secondary cold feed because it's on the hot water side. It's the pipe which feeds the hot water cylinder with cold water to be heated. Okay, so secondary cold feed comes from the cistern, goes into the bottom of the cylinder. It must have a means of isolation on it. It must have a full bore valve, for example, like a gate valve or full bore lever valve, so we can isolate the hot water side in case we need to work on it and carry out some maintenance. So the secondary cold feed must have a means of isolation on it, and it's a minimum size of 22 mil. We're going to sort of introduce you right now to the fact that the primary cold feed is different. Okay, it's good to make sure that we kind of cover this at the same time, so it saves confusion in the future. Okay, the primary cold feed, the one that we just talked about, that feeds the hot water, sorry, it feeds the central heating system. That is a minimum size of 15 mil, and it must not have any valves fitted on it for safety, essentially. Because under normal working conditions, actually, the cold feed pipe, be it on the secondary side or on the primary side, it's actually a first point where the water expands to, because when water's heated, it expands. When the water expands in this cylinder, the first place it's going to expand is actually through and into the cold feed, and it's going to cause the water level in the cold water storage system to sort of rise a little bit as hot water expands. Okay, and the same thing happens in the heating system. As the water in the heating system heats up, it expands, and the water level in the feed and expansion system will rise, because the water expands up the cold feed pipe through the cold feed pipe. Okay. The only time we ever really need the vent pipe is if there's fault conditions, essentially. The vent pipe keeps the system running at atmospheric pressure, and also sort of allows the water to expand if there is a fault. So yeah, secondary cold feed, minimum 22, must have a valve in it. Primary cold feed feeds the heating side, minimum 15, must not have a valve in it. So secondary open vent pipe, there's a few things we need to know about this. Okay, its purpose is to keep the system at atmospheric pressure, and it will also allow the water to escape if there was a fault and the water can't expand through the cold feed, for example, if this valve here has been shut off. Okay, the regs say it must have a minimum internal diameter of 19 mil. Okay, we would normally use 22 mil pipe. Okay, must not have any valves fitted on it, because it's a safety relief pipe, essentially. So any vent pipe, you should never ever fit any valves on any vent pipes. Okay, and where it comes off the top of the cylinder, it should run just past horizontal, just with a slight rise on it, for at least 450 mil, and that is to prevent something called one pipe circulation. Also, some people call it parasitic circulation. We briefly touched on convection earlier on, and essentially we talked about how hot water will rise and colder water will fall. And if this vent pipe came straight off the top here, all of the hottest water in the cylinder is just going to rise right up to the top of to the vent and cool in the pipe and start to fall back down, which essentially reduces the efficiency of the cylinder. So by taking this pipe 450 mil or at least 450 mil horizontally, then it would be, it essentially reduces that's at one pipe circulation. Okay. Another thing worth noting about the vent pipe is the height that it should rise above the water level in the system. And there's a quick calculation we can do to work that out. Essentially, the calculation is 40 mil. It should rise above the water level 40 mil per meter for every meter between the water level in the system and the bottom base of the cylinder, plus a set amount of 150 mil. So, example shown here is we've got 5 meters head between the water level here and the base here. So the calculation we'd do would be 40, which is a amount, times 5, which is the height, plus a set amount of 150, which would give us a total of 350 mil. So that's how much that should rise above the water level before being turned over back into it. And that's to stop it from sort of venting when it doesn't need to vent, essentially. Okay, so briefly going to look at our open vented hot water and heating system together. We can see we've got our secondary cold feed coming in here, 22 mil with the valve on it, going into the base of the cylinder. Our vent pipe coming off here, travelling horizontally for at least 450 mil to prevent one pipe circulation, and then rising above this system. Minimum size 19 mil internal diameter, normally use 22 mil pipe, and the height it should rise above this water level is 40 mil per meter plus 150. So that's the key things to remember. A primary flow and return for a gas or oil fired boiler would be a minimum of 22 mil for a primary flow and return. For a solid fuel boiler, a minimum 28 mil. On our primary side, we've got our primary cold feed coming from our feed and expansion here. Minimum 15 mil, must not have any valves fitted on it. A primary open vent, so minimum 22 mil or 19 mil internal diameter. And this actually should have a set amount. It should rise above the water level by 450 mil. That's just a set amount, and that's to reduce the likelihood of pumping over. Essentially, when the pump kicks in, you get like something called the surge effect. The water kind of gets pushed in front of it, and it can cause the water to sort of be pushed up and over and sort of go into the system. So we put that up 450 mil, at least 450 mil, to reduce the likelihood of it pumping over, essentially, on the primary side. But we'll talk about that in a lot more detail in the heating module. And finally, hot distribution, which is the pipe which delivers the water from the cylinder, from an open vented cylinder to our outlets. Minimum 15 mil, though our main ones would be 22 mil, and it should be 22 mil all the way to the bath on an open vented system because it's at lower pressure, and you need to get that to get a decent flow rate. Okay, so that is the end of part 1. We're going to look at part 2 in a minute. Okay.